Third principle, start small and simple. Small and simple. This is again probably one of the places where some of the biggest mistakes are made, is that the scale that is often that we often find ourselves working is not isn't the best. I'll say that. That sometimes you try to make features that are too large. Right? If you try to use features that are too large, you don't get very efficient use or distribution of the available water. So instead of having one huge pond, right, one huge feature where everything's focused, you actually might get more effective storage or use of water if you use lots of small, relatively small, and widely distributed storages. So one of the examples would be, we looked at the slide presentation of the Valrani cloud, right, the dolphin cloud. Right? So you had all these little basins, and the basins were connected, right, using the rip run. And so each of those basins stored roughly maybe 1,200 liters or 1,500 liters of water, but it was over, tens of hectares of land. So you're able to have a much more even distribution of water than if you had, say, one big dam in one specific place, and then you had to figure out how you're going to spread this water out over a large area. Okay, so small and simple. Start small and simple. Okay? And the other important thing about using small and simple solutions is that if they go wrong, if you get a failure, the failure isn't catastrophic. So, for example, if you have a huge dam or a big reservoir, and say the wall of the dam isn't made properly, and we'll take a look at how, again, some of those features are constructed. If the wall fails, you have a massive problem. Right? You have a huge volume of water that then ends up, again, traveling downhill, and invariably there's going to be people and houses and towns or something that are going to be located downstream. So if you have a centrally located, a huge volume, a huge amount of water where that could be a possibility, that's one of the downsides of relying on big features. If you have small, relatively small volumes of lots of storages, then you don't run the risk of that happening. And I'll show you one example of the effectiveness of using relatively small storage features spread over, again, a relatively large area. Now, I showed you the example of the Valrani cloud, right? Making the basements. This is even more simple. Same principle, but just somewhat, slightly different application. There's something called land imprinting. Land imprinting. How many people have heard of that? Imprinting. Yeah, I know you've heard of it. We probably talked about it. Imprinting is literally it's precisely as it sounds, where you take a tool and you're making like a little divot or a small basin, similar to what you saw with the Valrani cloud, but it's made in a different way. And so, let's take a look at this really quick. Yes, I'm sorry. Someone? All right, so land imprinting. This is actually something that it actually would probably work well here. I think it would work actually really well here. So this is a land imprinter, and it was developed by a gentleman named Dr. I think Richard Dixon. I can't remember his name right now. So basically the idea behind the use of the imprinter is that here you have a landscape that, again, is hard. You have a hard surface. That hard baked surface doesn't allow for the transfer of air and water across the boundary. So what has to be done is you gotta break the surface. You gotta actually allow for a passageway, a pathway, allowing for the air and water to move between the ground and the atmosphere. So the idea is if you can create that break, right, you now have the prospect of, again, some kind of growth because you're having a transfer of this essential resource. So the other great thing about the feature is it also creates a basin, right? You can actually collect water here, you can collect seed, you can collect organic matter. So the imprint allows for not only the movement of air and water, but it also gives a place to collect other things that are good for growth. So here, where is imprinting used? Okay. Imprinting is appropriate for use on abandoned farm fields and building sites, overgrazed rangeland, soils with rock up to 1 foot or 30 centimeters in diameter, and slopes as steep as 2 to 1. 2 to 1's like this. The technique, sorry, it's not quite. This technique is particularly useful for establishing vegetation on degraded lands with annual precipitation ranging from 3 to 14 inches, or 76 millimeters to 356 millimeters. Right, so that's precisely what you're dealing with here. You're smack dab in the middle of that range. And that's basically the description is what this place is, it characterizes this area. So you see the imprint is made using not an implement that digs. Actually, it's just teeth that presses into the ground. And then the pressure created by the teeth is enough to, if you have hard baked ground, it's enough to break the hard ground. And then again, make a little basin for it. So usually these are like iron teeth that are welded to a cylinder, and then it's pulled by something that makes the feature. Yes, Toby?
Which way are we looking at this? We're looking at the proof, is this sort of like a top-down, is this the shape that's going to be printed?
No, you're actually looking at a cross-section view. So it's like if you had a long piece of metal, and it's in the shape of like an L, right? That long piece of metal will be welded to the cylinder, right? So you'll see as we go into the other slide, right? So the idea is if we were looking at the top, this is a plan view. If you're looking down after the imprints have been made, the arrows are pointing towards the center of the imprint, which shows again where the water and everything else would collect. That's the idea, right? So it's going towards the middle of the imprint. Okay. So what you have here is again not only kind of a multifunctional element. Right? You've got the collection of seed, the collection of organic matter, the collection of water, and it's also allowing for the exchange of air and water, all in the same feature. So here's a couple of examples of what it might look like on a slope, how the arrangement of the teeth is different, what it might look like on flat land. And then here, how functionally what the imprint allows you to effectively put into use. So not only do you have a collection basin, you also have a way of being able to shield whatever's inside of this from the sun and the wind, because you do have something of a shadow that's cast if it's deep enough. So here's an example of what the tool looks like. So again, it's just like a cylinder. It's just a cylinder with bits of metal that are welded to it. And as it rolls, and sometimes the cylinder can be filled with water so it has enough weight, and then just under the weight of the cylinder, you create this little divot. You kind of collect this little collection point. Yes?
This technique, it would be useful in heavily compacted soils maybe further down the line.
Yeah, absolutely. Yeah, this would be like a first step that you would use in a place that's been, been heavily degraded.
And I've seen there's no compaction further down like this.
Oh, is there compaction underneath the surface? Sure, yeah, absolutely. I mean, so there's another tool that I'll show that kind of addresses that. The type of compaction you might be likely to have below the surface.
Do you expect the result of this to last for several years? Is this something that just do once before the rainy season, let's say, for the water to come in, but then next year realistically there won't be much left of it?
Wait for the slides coming up.
Okay.
All right, so there's another version. Right, it's a cylinder, again, lots of small teeth, just arranged in sort of an alternating kind of assembly. And this particular one is being used by a bulldozer. You can use it on a tractor, right? It's anything that has the power that can pull the machine. So you can see that this little kind of, sort of like a tessellation, really. It's like a tessellation, 3D tessellation. All right, so here's a beginning shot before, right? This is imprinting along with the application of seed, and here's an after. Right, so pre-imprinting, post-imprinting. Okay. Now the slides that you're going to see coming up are all examples of what's come from the use of the imprint. And I think what's particularly interesting is the amount of time that it takes for the vegetation to come back, right, through the use of this technique. So this is a place called Agua Blanco Ranch, Arizona. This is before imprinting. You can see it looks pretty bare. It looks pretty rough. That's before, during, and you can see all the features. After, that's 1 year.
Same season?
So go back and see again. Before,
Slower, please.
yep. So before, if you've ever been to the Southwest United States, that's where a lot of the, kind of arid areas, some of the deserts, like the Sonora Desert, is located in that part of the U.S. So it does, a lot of places look like this. So before, during the imprinting, and after. That's 1 year. In some cases, seed may be put down. In other cases, no. What you'll find is in many cases that a lot of these landscapes do have seed. It's just that the conditions that would allow for them to germinate just aren't there. So if you can help create those conditions, then the seeds have a chance to come up. Yes, ma'am.
So what season? Is it the same season in the first and last picture?
Oh, so what usually happens is you will do the imprint and the dry in preparation for the wet season.
Yeah, for the first picture, what season is the first picture taken?
Oh, this is likely probably early fall, late summer, because the rains are going to come, somewhere in the fall and then on through to possibly on through the spring. But again, depending on the nature of the climate, you do the work in the dry in preparation for the wet. I mean, just like what we saw with the Valerani plow, you do the plowing in the dry season in preparation for the wet.
And then that's the wet season, the second picture.
I'm sorry?
That's the wet season.
Yeah, so this is probably just after maybe the first couple of rains. 1 or 2 rains had a chance to actually get in the ground, and then this is the result after the seeds came up. Yeah. Here's another one. Agua Blanco Ranch, again, burrowweed. And so burrowweed is apparently like an invasive. So many of the areas that the work is being done in here is they're often places that are like ranch land, or what was previously ranch land, that no longer is being used for that purpose because the pastures have become really degraded. They're not actually producing grasses. So this work has been done to again open up the possibility of grasses to come back, but you need to get rid of the invasive growth first. So this is being used to crush. Sometimes it's being used to crush invasive growth so that it can actually make way for the grasses. Before, during, after. It's 1 year. Same place.
Again, please.
Yep. Before, during, after 1 year. Next, Agua Blanca Ranch again, another place. Now this is another invasive species in this part of the world. It's called creosote. So creosote's kind of it's a bit of a nuisance. So in this case, the imprinters used to crush the creosote. Right, so it's before, during, after 1 year. Now, it's interesting that it doesn't take long. If you do the right thing at the right time, it doesn't take long. Another one. Avra Valley, Arizona, before, during, after. It's 2 years.
Do you know whether they seeded in this case?
I'm not sure if this had been seeded, but in many cases, you don't necessarily need to seed to get this growth. I mean, many times they'll probably bring in something because there's a very specific outcome they're looking for, especially if it's going to be used for grazing. So they're likely going to put down some kind of seed that's good for livestock. But in many cases, it's just enough to be able to run the imprinter that'll allow for enough air and water to get below the surface so that you actually get the growth. Yeah. And that's the key. It's just initiating the process.
This is for a very specific problem on this, just a crust on that. What causes that specific problem that this would be used for?
Well, I mean, the crust, the baking of the surface is just due to the fact that whatever vegetation was on it was removed.
I'm sure that all of these are after overgrazing, like degrading.
Yeah, so usually a lot of these areas had previously been raised with large herds of livestock, and then the animals were eventually taken off, right? And then, I mean, this is kind of the odd paradox, is if you don't graze the animals properly, then you get a problem with grazing. But if you don't have any animals on land at all, the land dies. So the problem isn't whether or not you have livestock. The problem is whether or not they're being moved properly. If they're being moved properly, then it's not a problem. If anything, you're actually getting a lot of benefit. If you don't do it properly, then you have the condition where land is eventually it's not available to you. So it always comes back to the management. Always comes back to the management. It's not the animal's not the problem. Right? It's the management of the animal that becomes the problem. Here's another one. Continental Ranch, Arizona. Before, during, and I think there was some seeding here. After, that's 3 years. Before, you can see all the cactus along with the other, it's like probably creosote and another weedy growth. Before, during, after. It's 5 months. Again, timing. Being able to do the right thing at the right time, and most importantly, that this is work that's done just before the rains arrive. Right? It can turn over quick. Another one. Before, during, and you can see the cedar on the back. After, 1 year. Before, during, after, it's 4 months. Actually, it looks almost like rose grass. Right, so you see how thick it is. But again, the point being that what allowed for these things, for this effect to be had, was it wasn't like some massive amount of work that was done in having to dig and create places for water to collect. These are all relatively very small features. It's just that there are lots of them over a very large area. Right? Lots of them over a large area.